Welcome to this video on dimensional analysis and unit conversions. What we're going to do in this video is we're going to walk through some examples of using the dimensional analysis technique. These are going to be the same problems that you saw in the PowerPoint that were not done. So what might be a good idea is if you want to pause the video, pull up that slide or print out that slide that listed the problems, because those are the problems we're going to do in this video. And the very first one I want to do with you is a English to English conversion that you're probably already pretty familiar with. But I want to make sure that we do this with the dimensional analysis technique, because we're going to be using dimensional analysis for a whole bunch of problems this semester. So I want to introduce it in a way that you're already a little bit familiar with. So the problem was we needed to convert 0.0067 miles, and we needed to convert that to inches. So that was our ultimate goal in this. We would be provided some useful information in order to do that. So some things that would be provided for us: 12 inches in a foot, 5,280 feet in a mile. Those would be provided for us already, because these are both English to English conversions. You don't need to memorize any English to English conversions. So the first step in using this technique is to go ahead and start with your given information, 0.0067 miles. And what we want to do with this is we want to convert these miles into inches. And this is going to be a two-step approach. First, we're going to convert from miles to feet. Well, we already have the conversion, how many feet equal a mile. What we need to be able to do with this, though, is figure out what should go in the numerator and what should go in the denominator as we change this equality to a ratio. I already have miles in the numerator, so I want to put the miles in the denominator. That way they're going to cancel. I'm going to have the feet in the numerator. So that's going to be my next step that I have. The miles cancel. Remember, we're focused on the units, not necessarily the numbers. We're not even pulling out our calculators at this point in order to calculate anything. We make sure we get the units where we want them, and then we do all the calculation, all the math work at the end. Miles have canceled, numerator and denominator. Now I have feet. Now I can go from feet to inches. I have the equality between feet and inches. So now I need to use that equality, figuring out where I want the feet to go. Feet in the numerator, I want to go away from feet towards inches. So the feet are going to go in the denominator, 1 foot. 12 inches. Feet cancel. The unit I'm left with is the unit I want to be left with. Units of inches. That was my goal all along, to have units of inches. So what the dimension analysis does is it sets it up such that I'm definitely going to cancel off the correct units and be left with what I need. Now, dimensional analysis really just encodes a series of multiplications and divisions. I have this long horizontal line. That's really one big division bar. Anything in the denominator, I need to divide by. Anything up top, I'm multiplying by. So it's really a very efficient way to get a series of calculations in without really stressing about them. You're just focused on the units, and the numbers are going to take care of themselves. So what you're going to end up doing is you're going to multiply across the top. Then anything you have in the denominator, you divide by. Here it's just 1, so that's not going to change anything. But if you had numbers down here, you would just divide by that number in order to actually calculate this through. So when you do this, you would get 424.5 inches. Now, if you're worried about significant figures and rounding, you would realize, hey, I got way too many significant figures there. I only get 2 based upon my starting information. So I'd have to round to this point if I was worried about significant figures. If you weren't worried about significant figures, you'd just leave it. So I might round to that point. That would round down to 420. But then I'd kind of recognize this 0 is one of those kind of strange, ambiguous zeros. So to really be clear, if you cared about the significant figures, you would change this into scientific notation, and you would get the 4.2 times 10 to the second for your final value for this. So I wanted to do this first one as a way to introduce dimensional analysis to you. Are there other ways of going about these dimensional analysis problems? Yes. But as we get more and more involved with chemistry problems and longer and more challenging chemistry problems, we want to make sure we're able to use this technique to solve more complicated problems. So let's go ahead and do the next one. Next one we want to do is a metric to metric conversion. And in this metric to metric conversion, what we wanted to do is we wanted to change kilograms. So we had 0.45 kilograms, and we wanted to change that to milligrams. That was our goal. So here, this is a metric to metric conversion. Being this a metric to metric conversion, none of the conversion factors are going to be supplied. These come from you learning and memorizing those conversion factors, those prefixes. You need to supply metric to metric conversions for yourself. That's part of being metric fluent. So we're going to start this off the same way though. 0.45 kilograms. And we want to go at the very end, so I'm going to draw this out a little bit farther. We want to go to milligrams at the end. And sometimes you want to put down your final goal at the end just as a little subtle reminder that, hey, this is what I need to achieve before I'm actually done with this problem. Now, my strong recommendation is anytime you are going from one metric unit to another metric unit, so one prefix, kilo, to milli, that you do not try to do this in one step. Unless you are super great at metric, you are much better off doing this in 2 steps. And I want to show this in 2 steps. So whenever you're going from one prefix to another, first get rid of any prefix. So what that means is I want to get rid of kilograms and go to grams. I put kilograms in the denominator. That way they're going to cancel. Now I need to understand and write my own conversion for this. It's not supplied for me. I need to come up with this on my own. Well, kilo's 1,000, so what that means is 1,000 grams in that 1 kilogram. Kilograms have canceled. Now I have grams. I want to go to milligrams. Well, so I went from my old prefix to no prefix. Now I'm going to try to go to my new prefix, which is milligrams. Well, I want the grams to go away. I want to keep the milligrams. So now I need a conversion factor between milligrams and grams. And there's a couple you could write. One you could write would be 1,000 milligrams in 1 gram. That's a true statement because milli is thousandth, so it would take 1,000 of them. So that would be one conversion factor that you could write. There's another one. I'm going to put it up briefly in another color just so you can see that there's a different way of thinking about it. Instead of saying 1,000 milligrams in 1 gram, what you could also say is 1 milligram 0.001 grams. Kind of a different way of thinking about it, but you see that it's mathematically going to be the same. Multiply by 1,000 or divide by 1,000th, it really is not going to matter mathematically. Most of us would probably tend to think about it in the purple way, where we avoid the decimals and deal with the larger numbers as opposed to the smaller numbers. But if you think about it this way, that's perfectly good. Go ahead and use that. You'll get to the same spot. I'm going to take off that red so we're not too confused by that. Our grams have canceled. The unit we're left with, milligrams, is the unit we want to be left with. So at this point, it's about doing the calculation. Anything in the numerator is a multiplication. Anything on the bottom in the denominator is a division. So to actually get the numerical value for this, we'd go 0.45 times 1,000 times 1,000 divided by 1 divided by 1. You don't really have to do the divide by 1. That's not going to change the number. But if you did have actual values here that weren't 1, you would just divide by those. So when you go through that, what you would get would be 450,000 milligrams. If you cared about representing this in correct significant figures, well, you'd only get 2. You'd have to use scientific notation for that. You would get 4.5 times 10 to the 5th. 1, 2, 3, 1, 2, 3, 4, 5 milligrams for that final answer. So metric conversions would work the same way in this dimensional analysis technique. Remember, you have to be responsible for knowing the metric prefixes well enough to be able to write conversions like this for all of the ones that we ask you to memorize. So the next conversion we want to do is kind of a mixture of the first two. We kind of think about this as a mixture of the first two. We would have some English and some metric units that we would be trying to convert. So I want to do an example of that. And the one that we listed on the PowerPoint slides in the PowerPoint video is we asked you to convert 0.048 gallons, and you're trying to convert these to centiliters. That was your goal. Now you would be provided some things to help you out with this. So things you might be provided. 4 cups in a quart, you might have that conversion available. 2 cups in a pint, you might have that one available. You might have 4 quarts in a gallon. Available. You might have some other ones available as well. So far, these are all English to English conversions. Remember, you would need one way of getting between the English and the metric, because that's what the problem's really asking. Gallons English, centiliters metric. So in order to do that, you need at least one conversion for that property. And this one, the one that's supplied, is 946 milliliters, is 1 quart. So these are what we have available to kind of work with. It doesn't mean we have to use all of them. Sometimes you're given more than what you need, but that's what we have to work with. So even though this is using both English conversions and metric conversions, using dimensional analysis, it doesn't matter. It's still the same process. We start with what we know, 0.048 gallons. Now we know this is English, and we want to convert it at the end. I'm going to go ahead and do this. At the end, we know at the end we want to get centiliters out. So what that means is, some way I got to go from English to metric. So I'm going to look at what's provided, and I think it's a good idea to identify the key translator equality. The translator equality is that equality that you have available that relates the English to the metrics. Let's kind of pinpoint that. Cups and quarts, no, those are both English. Cups and pints, no, those are both English. Quarts and gallons, no, those are both English. Milliliters and quarts, 946 milliliters equals 1 quart. That is the translator equality that we have available for us. That translator equality moves between English and metric. Now that doesn't mean I'm necessarily going to have to use that one first or last. It could come somewhere in the middle. But I identified that right away because I know at some point I have to use that. There's no point but to. And sometimes when you identify that, you can also kind of see what your first couple steps might be. So if I know I have to use this, and I know the English part of this is in quarts, I have to get these gallons to quarts. So that kind of gives me a hint on where to start. So I need to figure out, can I go from gallons to quarts? What do I have available that can do that? Well, I can actually do that in one step. 4 quarts equals 1 gallon. I want the gallons to go away, so they're going in the denominator. 1 gallon, 4 quarts. My gallons have canceled. Now I have quarts. Why did I do that? Well, I did that because now I can use this key equality. I can now do that conversion between the English and the metric. So we're going to go ahead and use that. I want the quarts to go away. Quarts in the numerator, so I should put the quarts in the denominator. 1 quart, 946 milliliters. Quarts are going to cancel. Now I have milliliters. That's great. I'm in metric, but I'm not quite where I need to be yet. I need to be in centiliters, and I'm in milliliters. Now it's entirely possible and okay to do this in one step. I'm not going to advise it though, because generally we're not super comfortable with the metric system. Everywhere else in the world we probably try to do this in one step. But if you're not super comfortable in the metric system, I highly recommend you do this in 2 steps. And how can you tell if you're super fluent in metric? Well, if it took you more than about a second to come up with the single conversion between milliliters and centiliters, you had to think for more than a second, you should not try to do this in 1 step. Instead, you should try to do this in 2 steps. So I'm not going to go directly between milliliters and centiliters. If you immediately saw that and knew how to convert that, fine. Instead, I'm going to use the 2-step process. Whenever I'm going from one metric unit to another metric prefix, I'm going to first go through no prefix. So old prefix, no prefix, new prefix. Again, much safer unless you are super great at the metric system already. So I'm going to show this in 2 steps. Milliliters and liters. So I want the milliliters in the denominator to cancel. Liters in the top. Well, here's a metric to metric conversion. These aren't provided for you. You need to come up with this for yourself. So what's the relationship between milliliters and liters? 1,000 milliliters in 1 liter. So another way of thinking about this, and you could do this, this would be fine. Instead of saying 1,000 milliliters in 1 liter, you could also say 1 milliliter, 0.001 liters. That would also be okay. Milliliters have canceled. Now I have liters. Now that I'm in liters, I can go to centiliters. Well, I want liters to go away, so liters in the numerator, liters in the denominator. I want to be left with centiliters. I should stick that into that numerator. Another metric to metric conversion. Well, I need the conversion factor to go ahead and do this. Well, conversion factor would be 100 centiliters in 1 liter. You need to provide that for himself, knowing what centi means. Another way of writing this, and this would be just fine, is instead of saying 100 centiliters per 1 liter, you could also say 1 centiliter, 0.01 liters in the denominator. That's the same relationship, just expressed a different way. The liters cancel. The unit I have left, the centiliters, well, that's the unit I want. So what this says is I have this set up correctly. All my units have canceled off. Now it's just about doing the math. So anything in the numerator is a multiplication. So 0.048 times 4 times 946, times 1 if you need to, times 100, divided by everything you see in the bottom, so divided by 1, that's not going to change the number, divide by 1, divide by 1,000, divide by the 1 if you needed to for that. When you go ahead and go through that, you're going to wind up with your final answer coming out at 18 centiliters. Once you kind of round that to 2 significant figures if you need to use significant figures for that. So this is a 1, 2, 3, 4, 5-step problem. So this technique really shows you how you can organize units in order to solve multi-step problems very cleanly and very effectively in order to do things. The last problem I want to do for you is a density conversion. Generally, if you can do a density unit conversion using dimensional analysis, you definitely have dimensional analysis mastered. So I want to do one of these for you. Now I'm going to do the one that we put up in the PowerPoint slide. So in the PowerPoint slide, the one we put up is we went from an English density 6.23 ounces per cup, and what were we trying to go to? We are trying to go to a metric density, decigrams per milliliter. Well, we'd be provided some things to do this problem. So some things you might have available to you would be something like 16 ounces in 1 pound. You might have 2.2 pounds in a kilogram. You might have something like 946 milliliters in a quart. You might have 4 cups in 1 quart. These are all things that would be provided for you in order to solve this. And you might even get more than that. Now, the key thing in this is you're going to notice we start a little bit differently than we did before, and it's key to do this. This is a critical thing that you do this on the very first step, because you can actually make a mistake how you key this information in. When you have 6.23 ounces per cup, you just don't slam everything in that top box. Instead, you have to make sure what goes in the top belongs in the top. So I'm putting the ounces in the numerator, the cups, and just one, 6.23 ounces per cup. That's how you have to feed this information in to the dimensional analysis. If not, you're going to end up making errors. Same thing's kind of true for how we want to get our information out. Decigrams per milliliter. So what this really is this is really just both things rolled into one. I need to change ounces to decigrams, as well as changing cups to milliliters. It doesn't matter where you start at. Most of us generally try to start at the top. So if I'm trying to change ounces to decigrams, what I need is a way to get from the English ounces to the metric decigrams. So I need a English to metric conversion factor for weight or mass. Ounces and pound, that's both English, that's not going to work. Milliliters and quarts, well, that's metric in English, but that's volume. Here, this is the one. Pounds and kilograms. We're dealing with weight or mass, and we have both English and metric. That's that key conversion I know I have to use. So being I know I have to use that, that's going to kind of help tell me where to start this off at. If I have to use this, I need to be in pounds. Right now I'm in ounces. So that's telling me first step or first couple steps, ounces to pounds. Can I do that? Sure, I have a conversion for that. 16 ounces, 1 pound. Well, ounces in the numerator, I need ounces in that denominator. Pounds will go on top, 1 pound. Ounces have canceled. Now I have pounds. PD is kind of a short abbreviation for pounds. Make sure we have enough room to kind of fit this in. 2.2 pounds, 1 kilogram. Well, now I'm able to use this already. I'm going to go ahead and use this. Pounds in the numerator. I need to put my pounds in the denominator in order to cancel. So that's going to put kilograms up top. Pounds would cancel. Now I'm in metric. I have kilograms right now, but I'm not in the right metric. I have kilograms. I want to get to decigrams. Well, to go from kilograms to decigrams, you could try doing it in one step. I really don't recommend it. Much safer to do it in 2 steps. So instead of trying to do this in 1 step, I'm going to do it in 2. First step is going to be to get rid of my old prefix, which is the kilograms, numerator, denominator, and just go to the base unit, which is grams. So now I need a conversion between grams and kilograms. This is metric to metric. This isn't provided for you. You have to know the metric prefixes well enough in order to be able to solve these. The relationship between grams and kilograms is 1,000 grams in 1 kilogram. Kilograms have canceled. Now I have grams. Now that I'm in grams, I can go to decigrams. Old prefix, no prefix. Now I'm ready to go to my new prefix. New prefix I want is decigrams. I want to get rid of the grams, so decigrams in the numerator, grams in the denominator. Again, a metric to metric relationship. I need to know the prefixes well enough to be able to provide this. So the relationship between decigrams and grams is 10 decigrams in 1 gram. Is there another way of thinking about this? Sure, you could have had 1 decigram in the numerator and 0.1 grams in the denominator, and that would be just fine. Grams would cancel. Now I have decigrams. That's good. That's what I want. Here's the other place you can kind of fall into a little bit of a trap that you want to make sure you're avoiding. It's very tempting to stop here. You see decigrams, you're like, great, I'm done. Well, you're not done yet, because you also still have to go cups to milliliters. You want to make sure you avoid that kind of trap and make sure you complete the problem. Well, cups, English, milliliters, metric. In order to do this, I need a English to metric volume conversion. Well, that English to metric volume conversion is the 946 milliliters in 1 quart. I'm in cups, so before I can use this, I have to go from cups to quarts. Now here's where you got to be careful. Sometimes we can get into kind of a rut or a pattern and kind of do something without thinking about it. Cups is in the denominator right here. If I want cups to go away, I can't put it in the denominator here. I have to make sure I put it in the numerator such that it cancels correctly. You have to be very careful of that. Cups in the denominator, cups in the numerator. Those will cancel. They don't have to be close to each other to cancel as long as one's in the numerator, one's in the denominator. Now I have quarts. Now I can use my key conversion. Same thing. I have quarts in the denominator. So in order to cancel it, my next quart needs to be in the numerator. I'm going to put the milliliters in the denominator. Quarts in the denominator, quarts in the numerator, they'll cancel. I have milliliters, that's what I want. If I do a quick double check of kind of what I canceled off and what I didn't, I'm going to find there's 2 things I didn't cancel. In the numerator, the one thing I did not cancel was the decigrams. In the denominator, the one thing I did not cancel were the milliliters. What am I looking for? Decigrams per milliliter. So when you're trying to go through and solve this, here's how you would mathematically compute this. Everything in the numerator is a multiplication. So 6.23, if you need 2 times 1, times 1,000, times 10, times 4. Again, remember, you don't need to put the times 1. Everything in the denominator is a divide by then. Divided by 16, divided by 2.2. If you need to, you can do the divide by 1s. Divided by 946. when you go through and do this, what you'll end up with is you should end up with 7.48 decigrams per milliliter for what you're looking for at the end. And this has our 3 significant figures that matches our given thing if you're interested and need to care about significant figures. If not, kind of however you rounded was okay, but if you need to report it in appropriate significant figures, you get 3, and that's your 3 here. So these techniques that we did in this video, not only useful for doing these type of unit conversion problems, we're going to use this technique for the rest of the semester as we're doing kind of more actual chemistry problems instead of just unit conversion problems.